Let us start our class first by solving moment of inertia of hollow shell. There are two ways to solve this. We can integrate it and we can use the definition of moment of inertia, right? We can use the property of moment of inertia. Let us assume this is a hollow shell. Let us assume it is a hollow shell. And these are my axes of a different axis, right? Let us assume this is my x-axis, it is my y-axis, and it is my z-axis. It is a hollow shell. If I do it by integration, right? Let us first do it by integration. So what I will do, I will take a small ring type of element. I will take a small ring type of element on the surface of the hollow shell, which is at angular position theta from here and lies in between d theta. Can I take that ring? Yes or no? Can you tell me what is the radius of that ring? From this diagram, can you tell me what is the radius of that ring? If this radius is r, then radius of that ring, isn't it r cos theta? Yes or no?
Yes, sir.
So radius of the ring is r cos theta. And the width of the ring is r d theta. So what is the mass of that ring? Can I say it is the mass per unit area, which is m divided by 4 pi r square, multiply it with the area of that ring. What is the area of that ring? Can you tell me?
So 2 pi r cos theta r d theta.
Good. 2 pi r cos theta into r d theta. Now, so let us simplify it. 2 pi r I will cancel. So it is m by 2 r only. And okay, r square is cancelled. So m by 2 into cos theta sin theta, cos theta d theta. Good. Now what is moment of inertia of that ring about that axis y?
So m r square.
Dm into small r or capital R square?
So r cos theta square. Whole
Yes.
square, I mean.
Yes, r cos theta whole square. So di is equal to m by 2 into r square cos cube theta d theta. Now if I integrate this equation, I will find my total moment of inertia. Yes or no? Can you tell me for this, what should I take the limit of this integration?
So 0 to 2 pi.
0 to 2 pi. No.
2.
Yes, yes. What should be the limit? It's not 0 to 2 pi. Can anyone else?
Minus pi by 2 to pi by 2.
Yes, good. It is minus pi by 2 to plus pi by 2. Look, I am taking theta from here. So here theta is 0. And as the ring is covering both the halves of the spherical shell, so if I only move from 0 to 90 degree, it will completely cover the upper hemisphere. And if I make it from minus pi by 2 to 0, then it will be for the lower hemisphere. So it should be for minus pi by 2 to plus pi by 2. Yes or no?
Yes, sir. I didn't understand.
From theta equal to 0 to pi by 2, can you see for the upper hemisphere you can complete? You slowly vary this angle theta. Let us assume there is a rod. There is a rod connecting from this point to this point, right? And there is a rubber band, right? So if the rod is, and suppose there is some color on the rubber band. So if you are moving this rod from here, from horizontal line to this line, just imagine if your rod is here, then your rubber band is actually here on the equatorial plane. Yes or no?
Yes, sir.
Right. So if you vary this rod from this point to this point, can you see you can actually color the total hemisphere, upper hemisphere?
Yes, sir. Upper hemisphere.
And when you are bringing that rod to the lower hemisphere, theta will be negative because I have taken theta 0 here, and theta I have taken from here positive, in this direction positive. So when you are coming the lower hemisphere, it is negative. So that should be from minus pi by 2 to 0, and that is from 0 to pi by 2. That's why I have said it's minus 2 plus pi by 2.
Okay.
Alright, can anyone do that integration? Can I say it is 1 minus sine square theta into cos theta d theta? Why I have written it like this? Look, if I now take sine theta to be z, is cos theta d theta dz or not? Substitution, integration by substitution. Have you done this type of thing?
Yes, sir.
In integration? So if I put sine theta to be z, what is cos theta d theta?
DZ.
Dz. So what should be my integration here inside this integration sign? 1 minus
1
z
minus
square
Z
dz?
square into DZ.
Yes. Now do that integration.
So we have to change the limits also.
Yes, definitely. 1 minus z square dz. Now your variable is z. So when theta is minus pi by 2, z is equal to
minus 1 to 1.
minus 1, and plus pi by 2, z is plus 1. 1 minus z square dz plus minus 1 to plus 1. What is the integration?
So Z minus Z cube by 3.
Z minus z cube by 3. Yes. 1 minus 1 by 3 is 2 by 3. And another 2 by 3. I think it is 4 by 3. Do your own calculation.
Z minus Z cube by 3.
Yes, put the limits, na? Put the limits for z, minus 1 to plus 1.
Yes, sir. Put. So 4 by 3.
Yes, it is 4 by 3.
4 mr square by 3. Sorry, 2 mr square by 3.
So the answer will be 2 mr square by 3. You should remember this result. Moment of inertia of a hollow shell about any axis passing through center is 2 by 3 mr square. That is one method where we have used the method of integration. But the same question can be done even if we do not use integration. How we can do it? This method is very interesting, and you should learn this type of methods more. Right. For example, let us assume the same spherical shell where this is my XYZ axis, right? Suppose it is x-axis, y-axis, z-axis. Now tell me one thing. Ix means the moment of inertia about x-axis. moment of inertia about y-axis or moment of inertia about z-axis, are they different or they are the same?
So all are same.
All are same because it is a perfect symmetry. So Ix equal to Iy equal to Iz. Let us consider it to be I. Assume it to be I. Now if I take a single point on the surface of the sphere, right? Let I assume I have taken a small point of mass mi. Means this is an ith particle of mass mi. And the location coordinate of this point is xi, yi, zi.
See, it is on the XY plane.
It is not on xy plane. It is in a 3D plane.
Okay.
Z coordinate is not 0. If you want to locate this point in a 3-dimensional space, right, I will just show you. The point is lying here.
Like inside the room.
Yes, like inside a room. Good. The point P is here. Right, suppose this point is P. So if it is x, y, z, then in order to reach this point, you have to travel xi coordinate along x-axis. Then you need to travel yi distance along y-axis. Then you need to travel zi distance along z-axis. Now can you visualize the location?
Yes.
Yes or no?
Yes, sir.
Can you tell why is Ix equals to Iy equals to Iz?
It is perfect symmetry. If I can say that it is the axis of rotation, just rotate that ball and axis of rotation. You will find sometimes later this Ix is Iy. Yes or no?
Yes, sir.
Right. So Ix, Iy, Iz, they are same. There is no biasness anywhere. You can see everywhere you will find the same orientation of the body and the axis.
So means we can apply it where we see that there is symmetry all around.
Yes. In this type of symmetry, all of them are same. Now, can anyone tell me what is the moment of inertia about of this point, of this single point? This single point about, say, x-axis. A point mass is there. Forget about other masses. A point mass is there. So about x-axis, if I rotate this point mass, what will be the moment of inertia? About x-axis, this is point mass P lies here. So from about x-axis, I want to rotate it.
Sir, m into y square plus z square.
Yes, good. Because what is the perpendicular distance of this point P from the x?
Say y square plus z square.
Yes, look, this is the perpendicular distance. And that distance is, if this is perpendicular, so yi square plus zi square. So can I say it is mi into yi square plus zi square? Everyone should understand it. And if I give a summation sign before that expression, can I find that this is the ix of the total body?
So we will not do integration.
You can do integration, no problem. But I have I could locate a discrete object here. That is why I have written it here. If you want to do an integration of dm, you can also do it, no problem. Meaning is the same.
So will you please repeat how this expression comes?
Okay, let us talk about this z-axis. Okay, ix is this one, iz. Can you tell me what is the distance of this mass mi from z-axis?
X square plus y square.
From a z-axis, the distance is nothing but this one. Yes or no? The point mass lies at a distance, this one from z-axis, and this distance, can you see that this distance can be treated as the distance from xy plane, where this is xi and this is yi, and they are perpendicular definitely. Xi and yr are perpendicular. So what is this much distance? Is it root under xi square plus yi square only? Yes or no?
Yes, sir.
Similarly, for ix, I have written yz, and for iy, what I will write? What I will write? Iy,
Yes, sir.
X square plus Z square.
x square plus zi. Now, if I add all these ix plus iy plus iz, should I get 3i or not?
Yes, sir.
And inside the summation mi, what I will get? 2xi square, 2yi square, 2zi square.
Sir.
Yes or no? Bolo.
স্যার ওখানে এটা রুট হবে না?
Square, m r square.
R
This-
square is there.
ডিস্টেন্সটা যদি বার করতে হয় তাহলে রুট হতো, কিন্তু আমি তো তার স্কোয়ার করছি।
ও আচ্ছা আচ্ছা, হ্যাঁ হ্যাঁ।
এম আর স্কোয়ার হয় না, ডিএম আর স্কোয়ার।
হ্যাঁ স্যার, হ্যাঁ স্যার, ঠিক আছে।
নাও হোয়াট ইজ দিস? xi স্কোয়ার প্লাস yi স্কোয়ার প্লাস zi স্কোয়ার। Can you tell me, anyone, what is xi square plus yi square plus zi square?
The moment of inertia about origin.
Distance from origin.
And what is the distance from origin?
It's x square plus y.
xi square plus yi square plus zi square under root.
So that
Is it
summation
R
will
or
give the
not?
moment of inertia about origin.
It is r square or not? xi square plus y square plus zi square?
Yes sir.
Yes, sir.
Yes sir.
And for every particle it is only r, because all the particles are lying on the surface of the sphere only.
Yes, sir.
Have you got this logic? For every particle it is only r or not? So can I take this entire thing outside of the integration sign? And can I say it is 2r square summation of mi only, which is 2mr square? So what is I? I is equal to 2 by 3 mr square. Right? That is also another proof of the same expression. Now we have a solid sphere of mass m, radius r. How do I calculate the solid sphere moment of inertia?
So you have to apply integration.
Yes? Yes, we have to apply integration only. What type of elements I will take? Can anyone tell me?
It's a solid disk.
Disk. Much easier solution is available. Even if you take disk, no problem.
The hollow sphere.
Yes. If you take hollow sphere, it will be easier. If you take a hollow sphere like this, right, of some thickness, suppose, or some thickness, dr. Okay, let us assume this is a hollow sphere of radius r.
So what is the shape of a shell?
Shell is concentric shell. It's a concentric shell. Suppose this is a concentric shell of radius r and thickness dr. So if I integrate such shells from 0 to capital R, can I find a sphere? Yes or no? If I integrate such shells from 0 to capital R,
Yes, sir. The full square.
we'll get a solid sphere. Have you got the answer? क्यों पहले आंसर को तो okay, let us calculate it. What is the mass of that small shell? Can you tell me what is the mass of that shell? Yes. What is the mass of the shell, that small shell? Anyone wants to try? What is mass of the shell? Well,
3m r square dr by r cube.
Okay, how I can do that? What is the volume of the shell? First tell me what is volume of the shell.
So pi r square dr.
4 pi r square
It's
dr.
not pi r square, 4 pi r square. What is the area of the shell? Is it pi r square or 4 pi r square? 4 pi r square. So it is the volume.
Yes.
And what is the mass per unit volume? Divided m divided by 4 third pi r cube.
Yes, sir.
So dm mass for that small shell is 4 pi r, 4 pi will get cancelled out. So it is 3m into r square dr divided by r cube. Have you got it? Now what is moment of inertia for that small shell? Is it 2 by 3 mr square? Yes or no? So I is the integration of that. 2 by 3 integral of dm r square. Dm is 3m by r cube into r square means r power 4 dr. Integrate it from 0 to r. What is the answer you will get? 3 gets cancelled out, 2m r power 5 by 5. So 2 by 5 mr square will be the answer. Have you got it? Try it by taking discs. Right? Take it as your homework. You should find the same result. But instead of taking concentric spherical shells, try it by taking discs. Right? You should find the same result. Now you will study two theorem related to moment of inertia. One is perpendicular axis theorem. Another is parallel axis theorem. What is perpendicular axis theorem? Let us take one body. Suppose this is one rigid body. Remember, perpendicular axis theorem is only applicable for planar objects. Right? Only applicable for planar objects. So if it is a
of thickness.
yes, of negligible thickness, yes, of negligible thickness. So if it is a planar body, and let us
It means for spheres, it will not.
no, not for sphere. Yes, definitely not for 3D body. Only for planar object. Suppose this is my axis of rotation, right? It is my axis of rotation, and I have drawn another two axes also. So it is suppose x-axis, it is y-axis, and it is z-axis. Z-axis is the axis of rotation. About this point it is rotating. Now you take any small point mass mi. What will be the coordinate of this point mass? Will there be any z coordinate?
No, sir. X comma y.
X comma y. Xi comma yi.
Yes, sir.
These are the coordinates of the point. Now if I ask you, what is the moment of inertia of that point object about x-axis? What will be your answer?
Say mi x square.
mi? ভালো করে দেখে বলো তো।
Say mi xi square.
No.
Sir, mi y square.
mi
y
yi
Okay, y square. Yes, sir.
Yeah.
I square.
The perpendicular distance from the point to x-axis is yi.
Yes, sir.
mi yi square. Right? Z is 0. So summation of mi yi square is ix. Similarly, what is iy? Yes, what is iy?
mi
xi.
Yes. It is summation of mi xi square. Can you tell me what is iz?
summation of mi
Ix iy.
yi square.
X square plus y square.
Summation of mi xi square plus yi square. Now it is very simple to understand from these relations that iz is equal to ix plus iy. Yes or no?
Yes, sir.
Yes, sir.
So this is known as perpendicular axis theorem, which says that if the body lies in xy plane, then ix plus iy will be iz. If the body lies in yz plane, then iy plus iz equal to ix. Right? So I can find the moment of inertia about an axis perpendicular to the plane where the body lies with this theorem. But the condition that body must be linear or planar. Body must be planar object. Right? If it is not planar, then you can see that from all these two expressions there will be another z term, and then you cannot write this expression. Yes or no? So body must be planar. Is it clear to all?
Yes, sir.
Can you find the moment of inertia of that rectangular plate about this I1 and I2 axis that are shown in figure?
So for I2, is it m by 12 into b square plus a square?
I2, yes, good.
And sir, I1 will be 4 times I2.
Yes. Look, if I say this is my x-axis and it is my y-axis, do I know the moment of inertia about these two axes?
Yes, sir.
What is this one?
So this one m by 12 into b square.
mb square by 12, and what is this one?
M a square by 12.
Now can you see that I2 is perpendicular to these two axes?
Yes.
I2 is the addition of this two, m by 12 a square plus b square only. Similarly, do I know what is moment of inertia about this axis?
mb square by 3.
And about this axis?
ma square by 3.
So I1 will be m by 3 into a square plus b square. M by 3 into a square plus b square. Have you got it, everyone? Have you got it? Can you find moment of inertia of that cuboid of mass m about this axis? It's very simple. If you only find the moment of inertia of this plate,
So then we stretch it.
yes, about this axis, about its axis, this axis perpendicular to the plate, can I find what is moment of inertia of this plate? Yes or no? If I say it is x-axis, it is y-axis, and it is z-axis, what is moment of inertia about z-axis of that plate?
X
That's right.
This side is a and this side is c. So is it m a square plus c square
Yes.
divided by 3? Yes or no? Now if you stretch it along this line of rotation, axis of rotation, what you will get? The same cuboid or not? Stretch. Stretch rule we have used. So moment of inertia will be m. Do you remember the stretch rule? What we have studied in last
Yes,
class?
sir. It will have the same moment of inertia.
Same expression, yes. M a square plus c square by 3. That will be the answer. Next we will study parallel axis theorem. What is parallel axis theorem? Here we can use any body, be it a straight body or a linear object, be it a planar object, be it a three-dimensional or 3D object, anything. We can use this parallel axis theorem. But we will prove it by taking a planar object only, right? And you will see that this proof can be extended for any body because it does not depend on x, y, z coordinates. This theorem says that suppose there is one axis. This is my axis of rotation, right? Actually the body is rotating about this axis, but what I can say that there is another axis I have taken which is parallel to the first axis, but it is perpendicular to the center of mass of the body. So here IO is the actual axis of rotation. The body is rotating about this axis, but I have assumed, I have taken another point which is center of mass of the body, and I have taken a parallel axis. So if I say that the moment of inertia about this axis is IO, moment of inertia about this axis is IC. I have to find a relation between IO and IC, so that if I know IC, I can find IO. This is the parallel axis theorem. For that, let us assume one point. Suppose one point that is located somewhere here. Point mass mi. As it is for it may be 1D, 2D, 3D. So I will not take xi, yi, zi. Rather, I will take its position vector as ri. Can I say that ri is the position vector from O to that particle?
Sir, would you please tell that what is that axis along C?
What is the axis?
Sir, that red color line, sir.
This is the this red color line is the axis of rotation that passing through the center of mass and parallel to the original axis of rotation. Look,
Okay.
actually there is no axis like this red color axis. Actually the body is rotating about this axis, white color axis. But I have assumed there is another point which is center of mass, and I have assumed another axis parallel to IO passing through the center of mass.
Okay.
Clear? Now what I can write as IO? Is it summation of mi into
Ri square.
RS.
Ri square? Yes or no?
Yes, sir.
I can only write Ri like this. Can I say Ri is nothing but this vector plus this vector?
Yes, sir.
So what is this vector? RC or not? Can you tell me what is this vector?
RI minus IC.
Yes, what I will call it is RIC or not?
Sir, RIC.
Yes. Position vector of I with respect to C, it is RIC.
Yes.
So I can also write Ri vector is equal to RC vector plus RIC vector. So what I can write as IO, this is equal to summation of mi into RC plus RIC dot RC plus RIC. Can I write it? Dot product of two same vectors is nothing but their magnitude square.
Yes, sir.
Now I will expand this terms. So what is that first term? Yes, bolo. Look if I am writing right or not. MIRC square plus RIC square plus
2 sigma MI R IC. CIC.
2 summation of MI into RC dot RIC. Yes or no?
Yes, sir.
Now out of these three vectors, which one is a constant vector? Can you tell me?
RC.
RC is constant, yes. Because O is constant, C is constant. I is not constant. I may vary from point to point. So that is a constant. So if I take this constant out, can I only look the third term? Can I say it is 2RC dot summation of MIRIC?
Yes, sir.
Are these two things same or different?
Yes, sir.
Same. So can you tell me what is summation of MIRIC? What is the summation of MIRIC?
Sir, IOC.
No.
Sir, IC.
M into R is not I. M into R squared is I. So nothing is related with I, that term. Can you tell me what is summation of,
Sir, mass moment.
yes, what is mass moment about center of mass?
Yes, sir, mass moment about center of mass.
So what is summation of MI divided by summation of MI?
Center of mass.
Yes? Do you remember this formula?
Center of mass.
It is R of center of mass, yes or no?
Yes, sir.
Now from which point reference I have measured this position vectors?
From C.
From, no, this position vectors are measured from where?
Oh.
These are from origin or not?
Yes.
This position vector is also from origin? Yes or no?
Yes.
I have written this equation from origin. Now suppose I have changed my position of reference point from origin to center of mass itself. So can I say then I have to write summation of MIRIC? If I choose origin to be at center of mass, then what I will write?
It's a RIC.
And what will be this term?
0.
Is it RCC which is 0?
Yes, sir.
Because it is position vector of center of mass with respect to center of mass itself. Definitely it will be 0. So what is this term actually?
It is 0.
What is this one then?
0.
So the third part is 0. Now what about the first two parts? Summation of MIRC square. What is this one?
IC.
Can I say it is? No, it's not IC. RC square is a constant. Can I take it outside? So summation of MI is M.
RC into mass of the object.
Yes, it is MRC square only. Total mass into this distance square. And what is the second term? Can you tell me what is the second term? Is it
moment of inertia?
moment of inertia of what?
Sir, IC.
Moment of inertia of the body about center of mass or not?
Yes, sir.
So IO is equal to IC plus MR square. That is the parallel axis theorem. Very important to understand. IO is any axis of rotation. IC is any axis of rotation, not any axis of rotation. IC is the axis of rotation passing through center of mass and parallel to the initial or the original axis of rotation. Yes or no? So IO is the axis of rotation through O. IC is axis of rotation through C parallel to IO, and their relation is IO equal to IC plus MR square. That is why it is not parallel axis theorem, because IO and IC should be parallel to each other. Can I take any axis passing through center of mass? No. Which axis I have taken? I have to take only parallel, because through center of mass there are infinite number of axes possible, but I will only take parallel axis. Are we done with this? Yes, one more thing, that it is applicable for all the bodies, even if it is 3D. Applicable for all bodies. 1D, 2D, 3D, everywhere it is applicable. Is this clear? Let us see a few application of this parallel axis theorem. Can you find moment of inertia of this disk of mass m radius r about the axis shown in figure? Right. So you can see that this axis is x-axis, suppose. It is suppose x-axis, it is y-axis, and it is z-axis.
Sir, I1 will be 3 by 2 mr square.
I1 will be 3 by 2 mr square.
Yes, sir.
What about I2?
So same, I think.
No.
No, not same.
5 mr square by 4.
Yes, sir. 5 by 4 mr square.
Good. Good. How we can do it? Suppose it is the center and center of mass both. Can I find what is moment of inertia about these two axes first? Suppose this is I y prime z prime and this is y axis. This is z axis. Look, about all the axes I have drawn, about which axis of rotation the moment of inertia I know.
IZ.
IZ I know.
Z.
What
Sir,
is
Z.
IZ?
Of center of.
IZ equal to mr square by 2, yes or no?
Yes, sir.
Can you say that Ix and Iy are symmetrical? Same. Ix and Iy both are passing through the diameter? Yes or no?
Yes, sir.
For a disk, this axis of rotation and this axis of rotation, are they same or different? For a disk, same or not?
Yes, sir. Yes, sir.
Ix equal to Iy. And can I say from perpendicular axis,
IY equals to half of IZ.
yes, Ix plus Iy is Iz. So Ix equal to Iy, that is equal to mr square by 4. Now use parallel axis theorem. It is passing through center of mass also. So can I say Iz prime is equal to Iz plus mr square? Yes or no? Iz prime is equal to Iz plus mr square. Can I apply this concept in parallel axis theorem?
Yes, sir.
So Iz plus mr square is 5. Iz is mr square by 2. So it is 3 by 2 mr square. And also can I say Iy prime is equal to Iy plus mr square? Because now these two are parallel axes, one is passing through center of mass. So that is equal to mr square by 4 plus mr square. 5 by 4 mr square. That is the answer of this question.
Sir, how did you say that Ix equals to Iy?
Ix equal to Iy. Again, if you rotate this axis, you will find Iy.
Okay, sir, by that process. Okay.
Clear, everyone? Is it okay?
It is well.
Try
Sir, please
solving
show
this
that
question.
once.
Huh?
Sir, please show that once.
Yes.
Yes, sir.
Done. Okay. Can you try this one? When there is a circular section of radius r by 2 removed from a disk of radius r, as shown in the figure, right? Mass of the remaining section is m, right? So left out portion has a mass m. What is the moment of inertia of that system about this axis?
So,
Yes.
is it 37 mr square by 24?
37 you are getting. Okay. 24 will be there, but I am not sure whether it's 37.
Sorry, sir, 13.
Yes.
Is it 13?
Yes, I think that is the answer. How I can calculate it? Let us.
First find IC. We have to find IC and then transfer it.
But I can also use the superposition principle, that I will first find the moment of inertia of that entire disk about this axis. What is moment of inertia of this entire disk about this axis? Is it 3 by 2 mr square just we have done? Yes or no? What is the mass of this disk? The mass is sigma into pi r square. About the same axis, if I want to find the moment of inertia of this small disk, how do I find it? Let us first find the moment of inertia of that small disk about its axis, and that is equal to m prime, suppose its mass, into r by 2 square by 2. Yes or no? Can I write the moment of inertia of the disk about this axis is mr square by 2, where m prime is the mass of that disk itself. And what is m prime? I can say m prime is equal to sigma into pi r square by 4. Yes or no? And what is the distance between these two axes?
3r by 2.
3r by 2. So about this axis, the moment of inertia should be m prime r square divided by 8 plus m prime 3r by 2 whole square. Yes or no? So 9 by 4 plus 1 by 8. That means 19 by 8. 19 by 8 m prime r square. Yes or no? Now m prime is equal to m by 4. So it is 19 by 32 mr square. Okay. So if I now find the net moment of inertia, it is 3 by 2 minus 19 by 32. 19 by 32 into mr square. So that is how much it is? 16 into 3, 48 minus 19 is 48 minus 19 is 29, right? 29 by 32 mr square. But what is m? Again, you can see that small m is the mass of the left out segment. So can I say m minus m by 4 is equal to small m? So m is equal to 4m by 3. So multiply it with 4m by 3. 4 by 3 means 4 into 8. 8 into 3, 24. Yes. So it is 29 by 24 mr square, I think. It's not 19. It's 29 by 24 mr square. Can you do this one? It's a cylinder, the same similar type of question. Exactly similar. Find the moment of inertia of the solid cylinder of mass m. The inner radius is r by 2 and outer radius is r. The length is given L. How do I solve it?
So we can take the mass of that entire cylinder without that hollow thing. It will be 4m by 3.
Yes, if
So
you
and that
see,
mass of that means that thing which was carved in out, that will be m by 3.
yes, if I say there is a solid complete cylinder of radius r, length L, and if its mass is m, then m is equal to the density into pi r square into L. And if I have a similar cylinder of radius r by 2, then its mass is
So what is the answer? 5 by 8 mr square.
yes, yes,
So we
5
can
by 8.
calculate for a disk and then apply stretch rule.
Yes, also you can do it. So it is m by 4. So the mass m that is given in your question is m minus m by 4. Right? It is 3m by 4. Right? So m is equal to 4m by 3. Right? And m by 4 is equal to m by 3. So what is moment of inertia of this cylinder about this line? Mr square by 2. So it is 4m by 3 into r square by 2, and that is mr square by 2, but r is r by 2 here, mr square by 2. So if I subtract them, I will find the moment of inertia.
So it will be m by 3.
Achha, m by 3, yes. So it is 2 mr square by 3 minus 4 into 2, 8, 23. Mr square by 24.
mr square 24.
Yes. So 2 by 3 minus 1 by 24. 2 by 3 means 2 by 16 by 20. 16 by 24
16 by
minus
24. Minus 1 by 24.
16 by 24. Yes. If you cancel with 3, it is 5 by 8.
So what is the use of length in this case?
What is the use of?
Length n in this case?
No use. It is a stretch rule. You know, there is no use of the length. Can you find moment of inertia of that half disk? It is a half disk, right? And you have to find the moment of inertia of that half disk about this axis that is just opposite to the center of the disk, right? Like this. This is the half disk, just opposite to the center. What is the moment of inertia? Perpendicular to the plane. The axis is perpendicular to the plane. Do you remember the parallel axis theorem? What was the parallel axis theorem?
So first we have to locate the center of mass, then only we can proceed.
And
Yes,
what
sir.
is the center of mass? Is O the center of mass?
No, sir.
No, definitely not. O is not the center of mass.
Sir, is it simply mr square?
No. Look, I have drawn 3 different axes. One is IO, another is IC, another is I1 that I have to find.
Pi term should be there.
Yes, definitely there will be a pi term. Look, can I say this is the center of mass? Can you locate the center of mass here? What is the distance OC? Do you remember?
4 by 3 pi.
4r by 3 pi,
Yes, sir. 4r by 3 pi. Yes.
right? Then can I write this equation? IO is equal to IC plus m into 4r by 3 pi whole square.
Yes, sir.
IO equal to IC plus mr square. I can use this equation or not? And what is IO?
mr square by 2.
It is mr square by 2. Because it is a part of disk, I can add the similar part about the same axis of rotation in order to get a full disk. Similarly, what is I1 then? I1, what will be I1?
So IC plus m into r minus 4r by 3 pi.
IC plus m into?
So r minus 4r.
R minus 4r by 3 pi.
Yes, r minus 4r by 3 pi whole square.
Yes, sir.
Everyone should understand it. Every time whenever you use parallel axis theorem, you should include the term IC. Otherwise, for any axis, if you write I1 equal to IO plus mr squared, is it a valid equation?
No, sir.
No. You should pass through center of mass every time. Now you can find. Now I can replace IC is equal to mr square by 2 minus m into 4r by 3 pi whole square. Yes or no? Plus m into r square plus m into 4r by 3 pi whole square minus 2m r into 4r by 3 pi. You can cancel these two terms. So this formula will become 3 by 2 mr square minus 8 mr square by 3 pi. Yes or no? The question says a uniform rectangular plate has side length of L and 12. Plate is in xy plane with its center at origin and sides parallel to xy axis, passing through the vertex. XY axis passing through a vertex perpendicular to the plane of the figure is I naught. So suppose I am drawing an axis which is passing through point A and perpendicular to this plane. This is I naught. Now the axis is shifted parallelly to any other place. Suppose I am shifting this axis here. This position coordinate is x comma y. So that the moment of inertia about this point also remains the same. So what is the locus of that point? Right, suppose this is point P. So we can say that if I know moment of inertia about this center of mass O parallel to the axis, this one or this one, IO, then from parallel axis theorem, can I write I at A, that should be equal to I of O about O plus M into this square, and that square is equal to L by 2 and L square means root 5L by 2 means 5L square by 2.
Yes, sir. Yes,
5L square by 4, I think, right?
sir.
5L
Variance
square
na root से क्या?
but it's also a square. L by 2 square plus L square. So L square by 4 plus L square is 5L square by 4.
Okay.
Can I write this equation from parallel axis theorem?
Yes,
Similarly,
sir.
I can apply the same theorem for the axis passing through point P, and I can write IP is equal to IO plus M into what is that distance? Is it x square plus y
Square
square?
plus y square.
But according to your question, that should be is equal to IA. IP is equal to IA. So if I equate these two, you will get x square plus y square is 5L root 5 by 2L whole square. Yes or no? So
Yes,
that is
sir.
the equation of the locus of the point. Have you done it? This one?
Sir, can I see the answer?
Yes,
What
tell
have I
me.
got?
What you have got?
Sir, I've got 5 m square by 12.
5 ml square by 12. Okay. Anyone else got this answer?
Sir,
Right.
is that a frame or there's mass in that black
Frame.
space?
It's written. Okay, it may be anything. We can assume it to be a frame, also a plate. The answers will be different, but the process will be the same.
Sir,
Yes.
I got something like this, sir. Ma square by 12L into 2a plus cos square 15.
No.
Sir, cos square 15, sin square 15 are coming, but sin square 75 is also coming. So then it's becoming 1.
All right. So let us first solve this question for a
Please take it.
say for a plate, right? For a plate. For a square plate. Suppose this is a
Is
square
it
plate.
plate or frame?
Actually, it was plate. I have written it wrong frame. But again, the method is same. I will also do it for frame also, right? No problem.
Okay, sir.
Same method is there. Let us take this is a square, right? And if I ask you what is the moment of inertia of that square plate or frame, whatever it may be, about say this axis. If it is a plate, what is moment of inertia about this axis?
Is it going through the center?
Passing through the center, yes.
The ms square by 12.
And-
square by 12.
And about this one,
Ma square by 12 again.
Square by 12.
so if I say it is Ix, if I say it is Iy, then what about Iz?
It will be ma square by 6.
Ma square by 6, yes.
Yes.
Now, can you consider another two axes like this to be my x prime axis and just perpendicular to this to be my y prime axis
So x prime is where? Means
at any angle
is it
theta.
on the plane only?
Same plane. On the same plane, I have rotated the axis, xy axis.
Okay,
I have
sir.
just rotated by an angle theta. Now,
Sir.
the z axis is the same. Can you see z axis does not change here?
Sir.
Z
No,
is the
sir, it
same.
doesn't change.
Yes. So Iz remains the same. Now, can I say that Iz is equal to Ix plus Iy, and that is also applicable for Ix prime plus Iy prime?
Yes,
Yes,
sir.
sir. It is.
And if Ix equal to Iy, can we say that Ix prime is also equal to Iy prime?
So by virtue of symmetry.
Yes, sir.
Here, in case of a square, you can say, look, if I say x prime and y prime, right? Actually, if you just rotate this plate, right? If you just rotate this plate 90 degree, you will find that x prime will lie here and y prime will come here.
Yes, sir. Yes, sir.
Yes. And will the orientation of the plate change if you rotate it 90 degree? No. you will find the same configuration.
Can you please repeat this part?
The last thing I didn't get this thing.
I said that this ix prime and iy prime, they are also the same, because if you rotate that square frame by 90°, you will find the similar configuration. You can do it, you can try it by yourself. Let us assume it to be ABCD. These points are EF, G and H, and this is O. If I rotate this line by 90° anti-clockwise, then this
So
will
which
be
lines? So there are blue lines or red lines?
red lines. Blue line is Ix, Iy. I'm talking about this x prime. If I rotate it by 90°, now this will be your x prime and this will be your y prime.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Right? So if I rotate it by 90°, then A will come here, B will come here, right? So this point will be B, this point will be A, there will be your D, and there will be your C, like this.
So we are turning the rectangle square also, though.
That square, yes, that square. We are turning that square, right? So B, A, D and C, these points will lie like this. If I join them, you will find a square like this.
Sir, what about the points? These are why so much.
Yes, which points? Now this point,
So the points you drawn earlier, they are very much gap. So in the second figure.
in the second figure, yes, the points will be here. B is here, C is here, A is here, D is here. Right? Now you can see that these two Ix and Iy, I'm saying that Ix and Iy are actually the same orientation. Why? If I have rotated this, these two figures are very similar. You have to understand there is no difference between these two figures.
No difference.
Yes, sir.
Right? So as there is no difference, I can interchange Ix and Iy.
Yes, they are same.
Right?
Sir, no problem.
Right. So I can say that this is no change in the orientation. That I was trying to say. That if there is no change in orientation, then Ix and I prime will be the same. And can I say they will also be equal to Iz divided by 2.
Yes, sir. Obviously.
And they are also ml square by 12.
M square by 12. Yes, sir. Yes, sir. Okay, sir.
Yes.
Yes.
So in a square it is possible. If it were a rectangle, you could not do that.
That would be a square by 12.
M square by 12. But if it were a rectangle, we cannot say that. Right? You will find in rectangle, if you rotate 90°, if this side is shorter and this side is larger, in rectangle, if you rotate 90°, now this side will be larger and this side will be shorter.
You can do something else.
Yes. They will not be the same.
So we can imagine this coordinate is fixed with the square and we are rotating it and getting the same.
You can
figure
say
all the
that,
time.
yes. Yes. So m square by 12, I can find it. Now I will apply only parallel axis theorem. Now it is simple. Yes or no? Let us assume this again. Let us draw this figure. The same square. The same square is there. This axis, suppose this one is my x-axis. It is my x-axis, and this is my x prime axis, which I have tilted slightly by angle 15 degree,
Yes, sir.
right? So can I find what is moment of inertia about Ix prime, ms square by 12 or not?
Absolutely, sir.
Then I can just shift it parallelly from here to here.
And use the parallel axis theorem.
Sir, yes, sir.
Yes, but
So that is very good.
yes,
thing.
but if I have to shift it, it is center. Look, this is also passing through center, so it is IC, no problem. What distance I should know? The distance between these two parallel axes?
Sir, I mean a by 2, a by 2.
No, it's not a by 2.
A by root 2.
What is this distance? You should know. This distance, this perpendicular distance, you should know.
Yes, sir. 15. That's I'm saying.
What is this much perpendicular distance?
Just wait, sir, please.
This side is a by root 2. That we know. This side is a by root 2. Yes or no?
That angle is 15 degree. Then.
How much is this angle?
Oh,
This
a by root 2 cos 15.
No. How
That
much is this
height
angle?
will be.
Can you tell me how much is this angle?
$75.
So that's 30 degree.
Yes, that is 30 degree. How much is this total angle? It is 45 degree or not?
Yes, sir. That one is 15 degree. So this one is.
That
30
one is 15 degree. So that must be 30 degree.
Yes, sir.
So how much
That
is
will
that?
be a root 3 by 2 root 2.
A by root 2 into cos 30 degree or not?
Yes.
Can you get that geometry?
Yes, sir.
It is only a geometry now. Parallel axis theorem only I have to apply. If this is D, I can find the moment of inertia, that is ms square by 12 plus md square. Yes or no?
Yes, sir.
So what should be your answer?
ms square by 12 plus what?
D square means cos 30 degrees, root 3 by 2. Right? So 3a square by 8.
By 8. 8.
3a square by 8 plus 1 by 12. So 9 by 24 plus 2 by
Is
24.
it ms square by 3?
Right? Yes? No. Calculate it. I think it is 11 ms square by 24.
9 plus 2. Yes, sir. 11. So 11 square by 24.
11 ms square by 24. That is the answer of this question.
Oh.
Have you got the use of parallel axis theorem?
Yes, sir. I have got.
Right? We have done it for a plate, and in a very similar way, I can also do it for a frame. How can I do it for a frame?
So for a frame, we know the means
For
through
a
that
frame,
z axis.
what is Iz first calculate? What is Iz for a frame? Can anyone tell me what is Iz for a frame?
Say ms square by 4, no?
ms square by 4. How? What is Iz?
Sir, ms square by 3.
M square by 3. Okay. Each of the rod has mass m by 4.
Oh, sir.
So what about moment of inertia of a rod perpendicular to this plane passing at the center?
Sir,
Passing through
I'm getting ms square by 3.
What is the moment of
Sir,
inertia
4
of one
into
rod?
ms square by 3.
So I'm getting ms square by 4.
Okay, let me calculate. It is ml square by 12, ms square by 12 for each rod passing through the center. Yes or no? Now I will
Yes.
parallelly
Yes,
shift
sir.
that axis from here to here.
So you are taking through what, sir? Through O, no?
Through this point first, then point C, through point C. Parallelly I can shift it ms square by 4 with addition of ms square by 4. Then I can multiply it all
So
with
why you then by 4 here?
total mass
Oh,
of the
okay,
frame
sir.
is
Okay,
m.
sir.
So each of the rod has mass m by 4.
Yes, sir. Yes, sir.
At first you were calculating about which axis?
This term is about this axis, center of each rod. Center of each rod is ms square by 12
Yes, sir.
plus
Yes, sir.
parallel axis theorem.
Okay, sir. Okay, sir.
So it is ms square by 12 plus ms square by 4. So it is ms square by 3 or not?
Yes.
Can I use it?
Yes, sir.
Now I know
Yes,
what
sir.
is if
Multiply
iz
with
is this one,
okay.
then what is ix prime?
That is ms square by 6.
By 6. Then the moment of inertia d will remain the same or not?
Yes, sir. D will remain the same.
So it will be ms square by 6 plus md square. 3 ms square by 8. 3 by 8 plus 1 by 6. 3 by 8 plus 1 by 6. করো কত হয়?
13 by 24.
13 by 24. ms square. One by 6 plus 1 by 6 means 4 by 24 plus 9 by 24. Yes. 13 by 24. So that is the answer for a plate and that is the answer for a frame. Look, the
So means
processes
for a
are
frame
same.
we are taking it totally. So then we are just finding through the theorem.
Individually we have found from their center. Parallelly I have shifted it 1, then multiplied with 4.
So means we can do like this. So means we are finding, or we are adding on individuals about an axis, then using the parallel and perpendicular axis.
Yes. It is a planar object, we can use both. But if it were a 3D object, we cannot use the perpendicular axis.
Perpendicular axis, yes, sir.
Clear this one?
Yes,
Yes, sir.
Okay. So these questions are not very common in mains type, but in advanced type, you can expect this type of questions. Right. Now, can I find moment of inertia of the solid cylinder of mass m, radius r,
Yes, sir.
length l?
Definitely, sir.
Yes?
Yes, sir.
Yes. Have you done it?
So here perpendicular axis won't be applicable, I guess.
Yes. You cannot apply perpendicular axis.
So I didn't
Sir,
get
can I
the-
try once?
Yes? বলো কি করছো?
Sir, আমার ml square by 3 এসছে।
ml square by 3. No. Look here, as perpendicular axis theorem is not applicable, so we can only use integration. Right? When any theorem is not applicable, the only way is what? Integration. That
Yes,
is
sir.
applicable to everywhere. So let us assume this to be the solid cylinder. And this is the axis through which I have to find the moment of inertia. And I will take a small disk at a distance x, a small disk at a distance x from this axis. The disk has a thickness of dx. right? So I will first find the moment of inertia of this disk about this axis. Yes or no?
Yes, sir. Yes,
Then
sir.
I can shift it using parallel axis theorem. Parallel axis theorem I can use it.
Then integrate.
Then I will integrate. So what is the dm mass of that disk? Can you tell me?
dm. Yes, sir. It is density times pi r square dx.
Yes.
Rho into pi r square dx.
Put the value of rho in terms of m. Its mass is given.
Okay. So that is 3m divided by 4 pi r cube.
3m by 4. Why? It is
m by 4 by 3 pi r cube.
It is a cylinder. It's not a sphere. What is
Pi
the,
r square dx.
Speechless.
what is the volume of this cylinder?
Pi r square ho.
Pi r square L. Yes. What is dm mass?
Pi r square, and that's dx. Pi r square will cancel. M by L dx.
Yes.
So will it be m by L dx?
Yes. Look, r is same everywhere. The area is same, so it is directly proportional with length,
Okay.
right? So dm is m by L into dx, right? Can you tell me what is the moment of inertia about this axis?
The m r square by 4.
Yes.
It is m r square by 4. So I can write it as dm into r square by 4. Now if I
Yes.
shift this parallelly here, so what is di about this axis?
Di. So that is this dm r square by 4
Plus
dm into x square.
plus dm into x square? Yes. So now you can integrate this di to find total I. Yes or no? X will vary
In
from
parallel,
0
it will
to...
pass through the center of mass, no? The first one.
Yes, it is passing through the center of mass of the disk only.
Yes, sir. Yes, sir. Now just integrate.
Yes. Integrate and tell me what's the answer.
So I am getting m r square L by 4 plus m L square by 3.
M r square L. Where from you have got the extra L?
L will be cut.
Yes. The moment of inertia will be m r square by 4 plus m L square by 3. M r square by 4 plus m L
M
square.
r square by 4 plus m L square by 3.
Yes.
Yes, sir. Got it.
Have you got it?
Yes, sir.
Yes, sir.
Okay. So if you cannot apply theorem, apply integration.
Integration. So, but we have not used perpendicular axis.
Yes, we have used by when we have calculated that m r square by 4, dm r square by 4. When we wrote that, we have used perpendicular axis theorem.
Sir, can you show the solution?
Okay, sir. Okay, sir. Okay, sir. Got it. Got it.
Yes, that dm r square by 4, right? It is dm r square by 2 divided by 2, right?
Okay, sir.
Done. All right. Have you done this question?
See, this was homework.
It was also your homework.
Yes, sir.
So what's your answer?
স্যার বলছি এখানে কি ট্রায়াঙ্গুলেটর মাস বার করতে হবে সিগমা
কিছু করার দরকার নেই তো, মাস সিগমা দুটোরই সমান বলা ছিল। I have told you in last class.
Yes,
I
sir. Yes,
Yes,
sir.
sir.
You have told.
Sigma was same, so you do not have to calculate sigma separately.
Sir, I have a question, sir.
Yes.
So will the sir? I am not seeing the answer. Sir, of the lamina, will the moment of inertia be ma by 24?
I don't know what is the moment of inertia of that lamina, triangular lamina. You can calculate it. mh squared by 6 plus mh squared by 6. So that will be mh squared by 6 only. Yes or no? We have seen that.
But we have to find the limit of I guess.
Yes, in terms of I have to calculate. So that is why
Yes.
even if you do not calculate it, no problem. Look, here one thing you should understand, that suppose I have any arbitrary shape, right? Any arbitrary shaped object. And I know the moment of inertia about this axis is I. About this axis passing through its center of mass, right? Or about any symmetrical axis is I. Now I have the similar type of structure, exactly the same structure, but I have just made all the dimensions double.
Well,
All the dimensions I have made double. So what will be the moment of inertia of this
4
object?
times of that.
Yes?
4 times of that given.
How you can say it's 4 times?
so please wait, sir.
Because 2 square equals to 4.
It should be 2 times.
So because it becomes squared, that's
It is 2 times.
Look, the logic here that moment of
8 times. 8
inertia,
times.
This is a plane figure.
planar, yes, planar object.
So is it 8 times?
For plane figure, how much it will be?
Say 8 times.
so I personally think it's 4 times.
Why you are thinking 4 times? Is there any logic behind that?
So because in that case it's just that something like r square. In that way we do
No, sir, it will remain the same.
whole
So it will remain the same.
into whole
So it will
square is
remain the
4
same.
into that.
It will remain the same, sir.
No, it will not remain the same. Look, I is proportional to mr square, yes or no?
So will it become 8 times?
No, it will not become 8 times.
It will become 16 times.
Yes, it will become 16 times. Look, why
So
it will
how
become
exactly it is
16 times?
becoming? Oh yes, the mass doubles.
The mass
Or like
also,
4 times.
so
the
you
mass
can
also
say
becomes 4
that
times.
yes, it is if you dimension, if you analyze dimensionally, then it is L power 2, and mass is also proportional to L square,
Yes, sir.
right? So basically it is proportional to length power 4.
Okay, okay.
If it's a 3D figure, then it will become 64 times.
I'll come to the 3D figure. First, try to understand. In 2D, mass is also, if you increase all the dimensions double, then mass will also be proportional to area, not with proportional to length. So area
Yes, sir,
will
yes, sir.
become 4 times, right? So L square times, and R you are also making double, so there is also 1 square, right?
Okay,
So
so
that
length is to the power 4 it is raised.
I prime will be n power 4. If I make it n times, then n power 4i. Yes or no?
Yes, sir.
For 3D object, what can I say?
Say, what is n, sir? N?
N is the factor by which you are increasing.
The
For
dimension.
3D it will be n power 5.
Yes, for 3D, this will be n power 5. Because for 3D, I is proportional to again mr square. Now, m is proportional to what?
Oh, yes, sir. Yes, sir.
L cube.
L cube. Now, if you are not making the radius double, you are also making all the other dimensions double, right? That you have to understand. You are not only making the radius of the disc double, right? Or radius of the cylinder double. The length is also making double,
Yes, everything.
right? So, I can say that moment of inertia is proportional to L power 5 or not? So I prime is equal to 2 power 5 or n power 5. Ah,
So please wait a bit, sir. So means radius, length, everything will increase by factor of n.
yes. Right. So in this way, you can have an idea of moment of inertia of a bigger body if you can simulate the same body with a smaller dimension. Right. Suppose you have a statue of say several thousand feet or means several meter high, and you want to find the moment of inertia of that statue. So what you can do, you can build a similar statue,
Make them
right?
5 times.
Yes, and you can find its moment of inertia. Just multiply it with n power 5.
Sir, that is very
Yes.
peculiar way.
No, that is mathematical way. But in that case, the density or the material should remain the same.
It's uniform.
Yes. Now consider to this question that
But a very big statue itself doesn't have every part density uniform.
yes, but that is a you can say a means very crude way to find that. It's not a actual or exact thing you will find, but approximately that is the only way you can find it.
Yes. Through pen and paper.
Yes. Now you can see that now come to the question. There is a plate, a square plate is there, and a hexagonal plate is there. Sorry, a triangular plate is there, hexagonal plate is there. If you think about that hexagonal plate, look, I will again redraw that hexagonal plate. All the sides are of length 2a, right? All the sides are of length 2a.
Are of length what? 2a. Yes, sir. 2a.
It's given. Look. I
Yes,
have
sir.
to find moment of inertia about this axis. What I will do, I will now join these 2 points, extend these 2 lines.
Sir,
Can you
that
see?
didn't come to my mind.
But that is awesome.
That is one triangle. Now, what is the side of this triangle?
Sir, 4A.
4a. Because
Sir,
this
actually,
is,
how are we supposed to understand that we are going to extend it that way?
because you have to find similar figure to in order to write it in terms of I.
I tried to break it into small 6 triangles and that.
But again,
that
again
is
all
the
the
most
triangular
common thing
parts
that
will not
comes
be
in
the
mind.
same.
So then what to do?
Even if you break it in 6 parts, all the triangular parts will not be along this axis of rotation only.
Yes, sir. Somewhere outside and they were
Outside, then
getting.
you have to use the
Actually,
parallel axis.
if it is possible to just shift for a triangle
You can do
laminate
it.
to
You can
shift
do
it
it in that way
and
also.
then calculate for that.
Yes, but that will be a very lengthy calculation.
So why is the length 4a, sir, of this triangle?
If this is 2a, this is 2a. I have extended that side to form a equilateral triangle. So these sides will be 2a, 2a.
All are symmetric, no?
Now can you tell me what is the moment of inertia of this bigger triangular plate?
Yes, sir. It's 4 to the power 4 times.
It is? Yes, it's proportional to the n power 4. So if the side is a, my moment of inertia is I, side is 4a, means moment of inertia is 4 power 4i.
256.
256.
Now out of this bigger triangular section, if I subtract that smaller portion, I will get this part or not?
Yes, that is 16 times. So you have to subtract 16 times.
Minus 2 power 4i. And can I just multiply it with 2? I will find my answer.
Oh no.
Yes or no?
Yes, sir.
So how much it is? 256 minus
480.
16.
480i. 480i.
Yes, that is the answer of this question.
So that side length is 2a by symmetry. So means we are drawing an equilateral triangle.
Yeah, if you can extend it, it will be equilateral because all these angles are 60 degree.
Okay, sir. Okay, sir.
Have you got the solution?
Yes, sir. So please wait for a few minutes.
See, is there no formal way of doing this?
It is a formal way. What is any other way you can do it? Yes, definitely you can do it by
Very
using.
informal.
Yes, it is
So this was a bit out of the box.
yes. You have to look. My why I have taken this question. First of all, you should understand this part that I have discussed in left portion. That if I increase the dimension in that order, moment of inertia changes. And secondly, you have to always keep in mind that the first thing you should remember that if I can identify similar type of structure, then it will be always useful for us.